Okay, so now in the first half, we have talked about sampling distribution of the means. And in the second half, let's introduce sampling distribution of the proportion. Sampling distribution of proportion represents the distribution of all possible proportions from all possible samples. So first, let's introduce some definitions. The first is population proportion, with little pi to represent. So population proportion represents the proportion of the population having some characteristic, such as the percentage of population that have green eyes, or the percentage of population that are experts in swimming. Simple proportion we use little p to represent. So that means the proportion of the sample having some characteristic. And this little p or sample proportion is used to provide an estimate of population proportion pi. We use capital X to represent the number of items in a sample having characteristic of interest, and little n to represent the sample size. Then X out of n gives us the sample proportion P. Just like the central limit theorem, when a sample size is large enough, then the sample proportion P is approximately distributed as a normal distribution. So here you have to be very, very careful about sample proportion little p, because it is very easy to get confused between sample proportion p and the probability p-value. So we have been using probability p-value for a long time in normal distribution in the previous chapter, and we also use the probability in a sampling distribution of the means to calculate the probability for a given x. Okay, so when we calculate the probability, we always use p to represent, but that p is totally different from this p, the sample proportion. Okay, so please pay attention to the difference between the sample proportion p and the probability p-value. Okay, so when you solve a problem in sampling distribution of proportion, you have to check the condition first. The condition is the sample size multiply the population proportion has to be at least 5. And the sample size times 1 minus population proportion has to be at least 5 as well. You can only solve a problem in sampling distribution proportion once this condition is satisfied. Otherwise, you cannot proceed to solve this problem. So once this condition is satisfied, you can go ahead to solve this problem, and you will need two formulas. The first formula is for mean of sample mean. The notation of mean of sample mean is mu p. Mu represents mean, p represents sample proportion. So mu p represents mean of sample proportion. And that is always equal to pi, which is population proportion. Okay. Second formula is for standard error of sample proportion. We use sigma to represent standard error. We use p to represent sample proportion. So sigma p is standard error of sample proportion. And this is calculated from the population proportion pi and the sample size n. Okay. So once we have the formula for the mean of sample proportion and the standard error of sample proportion, and now we need the last formula, which is the z-value for the sample proportion. Okay, so this is the formula to calculate the z-value, which is the sample proportion minus mean of sample proportion divided by standard error of sample proportion. Okay, so this is very similar to the z-value that we use for the normal distribution. We have x value minus population mean divided by the standard deviation of population. But here we have to replace x with p. So just like we have the sample proportion minus the mean of sample proportion divided by the standard error of sample proportion. So just like we replace x with little p here. Okay, and then we plug in a formula for mu p. So we know that mu p is equal to pi, which is from this formula. So we replace mu p with pi. And we also know that sigma p, which is standard error of sample proportion, is equal to this formula. So we replace the sigma p with this formula, and now we have this formula for z value. Okay, so now we have all the formula we need to solve a problem in sampling distribution of proportion, and now let's take a look at the example. Okay, so now let's take a look at example first. If the true proportion of voters who support proposition A is population proportion equals 0.4, then what is the probability that a sample of size 200 yields a sample proportion between 40% and 45%? Okay, so now what information is provided? We know the population proportion is 40%. We know the sample size is 200. We also know there are two sample proportions. One is 40%, the second sample proportion is 45%. So the step 0 is to list out the parameters and check the conditions. So here is parameters. We have population proportion, we have sample size, and we have two sample proportions. Then we check conditions. So sample size 200 times population proportion 0.4 equals 80, which is greater than 5. So the condition is satisfied. And the second condition is satisfied as well. Then we proceed to the first step, is to draw the sampling distribution curve. And our goal is to calculate the probability of this highlighted green area under the curve. Step 2 is to find the z value from the sample proportion value. So all we need to do is very straightforward, is simply to plug in the number of parameters to the formula of z values. So these are the steps. So let's see. Let's solve for the sigma p, which is the standard error of sample proportion first. So we plug in the value of population proportion, which is 0.4, to pi. And then we plug in the value of sample size to 100 to little n. And we get the value for the sigma p, which is the standard error of sample proportion. Okay, so now we're done with the denominator. And now we need to plug in a value of p and pi to the numerator. So we know there are two p values. P1 is 0.4 and P2 is 0.45. So let's plug in the first p values first. So let's plug in the first p value, which is 0.4 minus pi. So pi is equal to 0.4. Okay. And then the denominator is already calculated from the previous step. And then let's take a look at the second z value. Second z value, we get P2, which is 0.45. So we plug in the second sample proportion 0.45 to the second z value. Then minus pi, and pi is 0.4. Okay, and divided by the denominator, which is from the previous step. And now we have two z values. z1 equals to 0. z2 equals to 1.44. And the last step is to find out the probability corresponding to the z value. Okay, so if z value is equal to 0, then the probability is 0.5. And this can be obtained from the z table. If z value is equal to 1.44, then the probability p value is 0.9251. So subtract the smaller p value from the greater p value, you get the probability of the highlighted pink area under the curve. Okay, so that's it for sampling distribution of the proportions.